What if I told you that the chair you are sitting on right now, the screen you are staring at, and the very fabric of reality holding your body together are fundamentally governed by rules that make absolutely no logical sense? Imagine a world where a single coin isn't just heads or tails, but somehow both at the exact same time, spinning in a blur of possibilities until the very second you look at it. Imagine being able to whisper a secret to a friend on Earth, and another friend on Mars instantly knows what you said, with zero time passing between you. No signals, no radio waves, just instant connection. It sounds like magic. It sounds like a glitch, but this is not a science fiction movie. This is the universe you actually live in. Today is April 14th, Hangin Layer, Sao, World Quantum Day. And the reason we celebrate today, the Bornth Day of the Bornth month, is because of a tiny, seemingly insignificant number. Born phi, born times my to the negative milum. That is Planck's constant. It is the fundamental speed limit and grain size of our universe. It is the mathematical proof that reality is pixelated. For the longest time, the bizarre rules of quantum mechanics were just math on a chalkboard. It was something physicists like me debated in cold laboratories, arguing over Schrödinger's cat or the double-slit experiment. But something massive has shifted. We have stopped just observing the quantum world. We have started engineering it. We are officially breaking the matrix. The technology we are building right now in Hangin Layer Sao is no longer theoretical. It is actively tearing down the limits of classical physics and reshaping global infrastructure. But because the quantum realm is so completely strange, the public conversation is full of misunderstandings. So today, let's clear the fog. Let's talk about what is actually happening behind the closed doors of tech giants and national labs. The biggest quantum myths. The most common thing I hear from people is this idea that a quantum computer is just a really, really fast, regular computer. I need you to forget that idea entirely. A quantum computer is not a faster version of the laptop sitting on your desk, in the same way that a light bulb is not a faster version of a candle. It is a completely different technology built on completely different physical laws. Your regular computer, your phone, the servers running the internet, they all speak a language of classical reality. Binary, ones and zeros, yes or no. True or false, everything is rigid. Everything is certain. But the quantum universe does not care about our need for certainty. Quantum systems use qubits. And a qubit doesn't have to be a 1 or a 0. Thanks to a bizarre property called superposition, a qubit can be a complex combination of both at the same time. It exists in a cloud of probability. If a classical computer is a person trying to find their way out of a maze by walking down every single path one by one until they find the exit, a quantum computer floods the maze with water, exploring every single path simultaneously. The second massive myth is that quantum technology is a distant, futuristic dream. People think, oh, maybe my grandkids will see this. No, it is happening right now. For decades, the challenge was keeping these qubits stable. They are incredibly fragile. The slightest change in temperature, a stray microwave, or even a cosmic ray from a distant star can cause a qubit to collapse out of its quantum state. That's why we have to build these massive, beautiful golden chandeliers called dilution refrigerators to cool the quantum chips down to fractions of a degree above absolute zero, colder than the vacuum of deep space. But here in Hangin Layer Sao, the progress in error correction has been staggering. We are no longer just celebrating the theory, we are celebrating the deployment. Which brings us to the things happening right under your nose. Real-world impact, you didn't notice. You might not have a quantum processor in your pocket yet, but the ripple effects of this technology are already brushing against your daily life. Let's start with something invisible but incredibly vital. Quantum sensing. Because qubits are so painfully sensitive to their environment, which makes them hard to compute, with that exact same fragility makes them the most perfect sensors ever conceived by human minds. We are using quantum sensors today to detect minute changes in gravity. We are talking about mapping underground structures, finding hidden water reserves, and optimizing real-time supply chains without ever digging a hole in the ground. Then there is the medical frontier. Classical computers are terrible at simulating nature. Why? Because nature is not classical. Nature is quantum. Trying to simulate the exact molecular structure of a complex protein using binary code is like trying to paint the Mona Lisa using only a black and a white crayon. It doesn't work. But quantum computers naturally speak the language of molecules. Today, pharmaceutical researchers are running early-stage pilot programs using quantum algorithms to simulate complex chemical reactions, radically accelerating drug discovery. But it's not all just saving the world and making things more efficient. We have to talk about the dark side. We have to talk about the security threat. Right now, every text message you send, every bank transfer you make, and every state secret guarded by a government is protected by mathematical puzzles. Systems like RSA encryption work because classical computers would take thousands of years to factor massive prime numbers. It's a lock that is practically impossible to pick. But a mature quantum computer? It doesn't try to pick the lock. It just bypasses the door entirely. This has led to a terrifying reality known in the industry as harvest now, decrypt later. Bad actors are actively sweeping up vast oceans of encrypted data right now. They can't read it today, but they are hoarding it in giant server farms, patiently waiting for the day a fault-tolerant quantum computer comes online. The moment that quantum leap happens, every classical password, every encrypted file, every secure network from the past 2 decades becomes an open book. That is why the transition to post-quantum cryptography is happening right now. Standards bodies aren't waiting. The shift is already underway to build digital armor that even a quantum computer cannot break. Your digital life is actively being migrated into a post-quantum reality as we speak. The ultimate future of computing. So, where does this all go? If classical physics is hitting a wall, what does the ultimate future look like? It looks like a hybridized reality. We aren't going to throw away classical computers. We are going to use them to manage the quantum engines. Think about spooky action at a distance. Entanglement. This is the concept that Albert Einstein famously hated because it felt like a violation of the laws of physics. You take 2 particles, you entangle them, and you separate them by thousands of miles. If you measure the spin of one, the other instantly, inevitably, snaps into the corresponding state. We are actively laying the groundwork for a quantum internet using this exact principle. A network that doesn't just transmit data, but transmits the quantum state itself. An unhackable network, bound by the literal laws of the universe. If someone tries to intercept an entangled message, the very act of them looking at it destroys the superposition. The eavesdropper physically breaks the message just by observing it. It is the ultimate security. The next 10 years will see the rise of fault-tolerant quantum computing. We are moving beyond the noisy, error-prone machines of the early high-end-layer high-MUIs and stepping into an era where logical qubits can correct their own mistakes in real time. This isn't just an upgrade. It is a fundamental evolution in how a civilization processes information. And that means we need people. We don't just need people with PhDs in theoretical physics. We need engineers to build the cooling systems. We need software developers who can think in probability instead of binary. We need ethicists, communicators, and policymakers. This technology is too powerful and too weird to be kept entirely in the hands of a few tech giants. It requires a massive public conversation. A quantum thought experiment. Before we go, I want to leave you with a thought experiment. Something to take with you the next time you walk outside. Imagine you are holding a compass. A classical compass points north because a tiny magnetic needle physically aligns with the Earth's magnetic field. It's simple mechanics. Now, imagine a quantum compass. In biology, there is a phenomenon observed in certain migratory birds, like the European robin. When they fly thousands of miles across the globe, they don't have a map. They don't have GPS. Deep inside their eyes, there is a specific protein. When a photon of light hits this protein, it creates a pair of entangled electrons. These 2 electrons, bound together by spooky action, are incredibly sensitive to the Earth's magnetic field. As the bird turns its head, the magnetic field alters the spin of these entangled electrons, changing the chemical output of the protein, and literally projecting a heads-up display of the magnetic field directly into the bird's vision. The bird isn't using a mechanical needle. It is navigating the planet by actively feeling the quantum entanglement of subatomic particles in its own eyes. Nature has been using quantum mechanics for millions of years. We are just finally catching up. So the next time you look at a bird flying overhead, or you look at the screen of your phone, or you look at your own hands, remember that the solid, predictable world you think you live in is just the surface of the ocean. Underneath, in the deep water, Reality is buzzing, branching, and existing in a million places at once. Welcome to the quantum era. It is bizarre, it is beautiful, and it is just getting started.